In this question, we are expected to show that AB transpose is equal to B transpose A transpose. So to do that, we would first consider A to be equal to 4, 6, 2, 0, 1, 5, 0, 3, 2, and matrix B to be equal to 0, 1, negative 1, 3, negative 1, 4, negative 1, 2, and 1. So we would now first start out with AB, because our intention is to show that AB transpose is equal to B transpose A transpose. So hence we need to take the product of AB, which is obtained as follows. Write the matrix of A and then the matrix of B, and now we will be multiplying matrix A with matrix B. The row goes with the column. So that would give us 4 times of 0, positive 6 times of 3, positive 2 times of negative 1. Now I would take the second row with the first column. Rewriting that would give me 0 times 0, positive 1 times of 3, positive 5 times of negative 1. Following it up would result in giving us 0 times 0, positive 3 times 3, positive 2 times of negative 1. Now it would be the first row, second column. So 4 times of 1, positive 6 times of negative 1, positive 2 times of 2. And then the second row with the second column, which is 0 times 1, positive 1 times of negative 1, positive 5 times of 2, and follow it up with the last set. Matrix that we would be getting upon simplifying. So it's going to be 0, positive 18, negative 2, and 0, positive 3, negative 5, and 0, positive 9, negative 2. For the second column, it will be 4, negative 6, positive 4, 0, negative 1, positive 10, and 0, negative 3, positive 4. And for the last column, it's negative 4, positive 24, positive 2, and 0, positive 4, positive 5, and 0, positive 12, positive 2, which can be further simplified to obtain 16, negative 2, and 9, negative 2 would give me 7, and that would be 2 and 9 and 1. The last column would give me 22 and 9 and 14. So this is the matrix for AB. Now we are expected to obtain the transpose of this matrix, AB transpose. That would mean I would now change the columns into rows, and likewise. Okay, now to find B transpose times A transpose. We know the matrix B in this case, which is 0, 1, negative 1, 3, negative 1, 4, and negative 1, 2, and 1. And the transpose of this matrix would be 0, 3, negative 1, 1, negative 1, 2, and negative 1, 4, and 1. Similarly, we know the matrix A given to be as 4, 6, 2, 0, 1, 5, 0, 3, 2. The transpose of matrix A would be 4, 0, 0, 6, 1, 3, 2, 5, 2. So we need to obtain B transpose times A transpose, which can be obtained as follows. So let's rewrite the matrix for B transpose and then follow it up with the matrix for A transpose. Now we would perform the product multiple for these two matrices. So that would be 0 times 4 positive 3 times 6 positive negative times 2, and then 1 times 4 is actually the second row versus the first column. So that would give us negative 1 of 6 positive 2 times 2, and then negative 1 of 4 positive, that's third row with the first column, positive 4 of 6 positive 1 of 2. Continuing in this like fashion, we can obtain the values for column 2. And then follow it up by obtaining the values for column 3. So now after we have done this, we are expected to achieve the simplified form. So that is going to be 0 positive 18 negative 2, 4 negative 6 positive 4, negative 4 positive 24 positive 2, and the 0 positive 3 negative 5, 0 negative 1 positive 10, and 0 positive 4 positive 5. For the last column, it's going to be 0 positive 9 negative 2, 0 negative 3 positive 4, 0 positive 12 positive 2. This can be further simplified and written as 16, 2, and that would give me 22. And the second column, the entry would give me negative 2, 9, 9, 7, 1, and 14, which is equal to the left hand side. Hence the proof is complete.